Welcome friends, greeting from Skills Up to Date YouTube channel, and in today's tutorial we are going to learn about Lambda expression and functional interface. But before starting the tutorial, may I request my viewer to kindly subscribe our YouTube channel Skills Up to Date and like our videos. Now to start with the Lambda expression is a new Java 8 feature, but to write a Lambda expression before writing, we need to understand the functional interface. So what is a functional interface? A functional interface is a type of interface which has only one abstract method. Here is an example of functional interface which has only one abstract method. The interface is add number interface, and it has the abstract method add to number. Now the functional interface can be annotated with a functional interface annotation. This functional interface annotation is new in Java 8. So if I annotate the interface with functional interface annotation, it looks like this. But the functional interface annotation is not a mandatory requirement, but it tells the compiler that the interface is a functional interface. Let's look with some example. Okay, so now I'm in Eclipse, and here is add a number interface, and it has an abstract method, and it has an annotation functional interface. Now since we have put the functional interface, now if I going to write another abstract method, public void say hello. Now what will happen? As soon as I write a new abstract method, the functional interface is going to throw a compilation error, because when you're adding a new method, it is no more a functional interface, because functional interface should contain only one abstract method. But if I remove the functional interface, then the compilation error gone, because normal interface can have more than one abstract method. So that's why I recommended, if you want to write a functional interface, please annotate the interface with functional interface. So beside the beside a functional interface abstract method, the functional interface can contain a default and static method. Now the default and static method has been introduced in Java 8. So like any normal interface, functional interface can contain a default and static method. But if you look, the functional interface, although the functional interface annotation is newly introduced, but the functional interface is not a new concept in Java 8. There are few interface with only one abstract method, like runnable interface, which has a run method, comparator interface having a compare to method, callable interface, call method, action listener interface. There are few already pre-existing interface there which can be considered as a functional interface. Now Java 8 further introduce a package, Java util function, and that package has a lots of predefined functional interface. So there are few very common functional interfaces: consumer interface, function interface, predicate, and supplier. There are many more functional interface, but these four are key types of functional interface introduced in functional interface package. When we are going to learn about the stream, we will see how we can use this functional interface. I hope now you all have got an idea about the functional expression. Now we are going to know what a lambda expression is. A lambda expression is an unnamed function having a list of parameter and body. So what a function or method has, they has a method name, return type, parameter list, and body. So but lambda expression is an unnamed function. So here is the syntax of the lambda expression. Here is a list of parameter, then an arrow and single line expression, or it can have a method body or method statement in case of multi-line expression. So these two from that lambda expression can have. An arrow is used to separate the parameter list from the body. Like here is the parameter list and then the body. So here is an example of the lambda expression. In this lambda expression, we are simply printing a string type of variable using system out println statement. So this is the string x is the parameter list, and system out println is the body of the function. And we can further shorten the lambda expression by ignoring the data type in the parameter list. So we can simply rewrite it without mentioning its string, and the compiler will resolve its type by comparing the type with the functional interface. So lambda expression, when you say the lambda expression, it's applicable in the context of functional interface only. So lambda expression actually implement the abstract method of the functional interface. And lambda expression is actually the implementation of the functional interface which have only one method. So here is a functional interface on the is a type, and we have the lambda expression, and it is, you must remember, the lambda expression can only be assigned to a functional interface. It can only implement a functional interface and nowhere else. But a functional interface can be implemented with the anonymous class or a normal conventional way of writing a code, writing a class which extends the functional interface. But the lambda expression is a shorthand implementation of the functional interface, and it can applicable only to the functional interface context. We have so far learned that lambda expression is an unnamed method, and the lambda expression is always going to implement an abstract method of the functional interface, and it always assigned to a functional interface. So now we already have seen this add number interface which has an abstract method to adding the two number. Now we are going to implement this functional interface using a lambda. So here is my Eclipse editor, and here is the functional interface of add to number that we are going to implement using the lambda. Since the left side is always a functional interface, so I have created a variable of type add number interface. Now we are going to implement the add to number method using lambda. So first, while we are writing the lambda expression, so there will be a parameter list and body. So here the add to number method taking to integer as an argument. So we are copying this parameter type and printing here and paste it, and now we have done with our parameter list for lambda expression. Now we have to implement the body of the lambda expression. So we need to add the two numbers A and B, and the lambda expression will automatically return the result. So we are done with the implementing the add to number method using the lambda expression. Okay, so now we can test this lambda expression. So we are writing a system out statement here, and here add to number, and now we are calling the add number method. So now if we are going to execute this program, and we can see we can get the result add to number, adding 10 and 30, we can getting the output as the 30. So we have added the two number 10 and 20. So now we can see how we can write a shorthand lambda expression which can implement functional interface method. Now let's look at the benefit of the functional interface. So add to number interface in a conventional way, if you write that add, we can also implement the add number interface in a conventional way, right? We can further shorten the lambda expression body by removing the data type of the parameter. So we can remove this to integer. So if you are removing the data type, then you should remove the data type of all the parameters. So we have removed the data type, and now if we are going to execute, we can get the same result. So we are adding a 10 with 20 and the result is 30. So we are getting the same. So we can we don't need to mention the data type. The compiler will check the interface abstract method type and automatically resolve the data type. Now what is the benefit of the functional interface using Lambda expression? So let us look at this functional interface again. So we can implement the functional interface using a conventional way by creating a class and that implements the add number interface and then we implement the abstract method. This is one way. But we have also know a shorthand way of using the anonymous class. So the anonymous class is still the shortest way of writing the code. So we can write the anonymous class here. Add number interface and here we have to override the method. Okay, now we are done with writing anonymous class. Now we can also execute the data using the anonymous class. Also execute the functional interface using the anonymous class. So here is the implementation 2, add number implementation 2. Now if we execute the code, we can also see that we are getting a result of 10 plus 20 equal to 30. But as a difference, you can see using the Lambda expression, we have our code has been just reduced to a line. But using even the anonymous class, we have write many 4 or 5 lines of code. So using the Lambda expression, it's a coding become much shorter and very small. So very small in size. Now, so far we have written a simple expression, a single line Lambda expression like adding to number. Now we are going to write a more complex Lambda expression where it's required a multiple line of code to implement the Lambda expression. Let's consider this problem. We are writing a program to evaluate the human life cycle stage based on the age. For example, if the human age is 0 to 3 years, then the life cycle stage is infant. Between 3 to 12, the life cycle stage is a child, and 12 to 18 is a teenager. 18 to 65 is an adult, and more than 65 the life cycle stage is old. Now if I try to implement that using a Lambda expression, so for Lambda expression, first things we need to write a functional interface. So a functional interface, here I have written a functional interface, human life cycle having only one abstract method, get life cycle stage, which is taking an argument of type double, which is actually the age, and it will return a string which will be life cycle stage like old or child. Now let's go to the Eclipse and try to implement the human life cycle interface. So I have already written the human life cycle interface, which having a get life cycle stage method. Now we are going to implement that using a Lambda expression. So first thing is the parameter list. So it is taking a age parameter of type double. So we need a parameter list. Let's say the variable x denote the age. Now we have to give the arrow symbol, and then we are going to implement the body of the method, means whole logic where we determine the life cycle based on the age. So I have already written that logic to save the time. Now let's copy it from my notepad and I'm going to paste it here. So now we have implemented the human life cycle interface using the Lambda expression. So it is a simple if-else logic which will compare the age and return the life cycle stage. Now if we are going to execute this program using a system out println statement. So I have given the age as 20 and a half, which will be an adult. So if I going to save and execute this program, yeah, you can find that the program is returning adult. And now we can change it to let's say 13 years. For 13 years it will be a teenage. Yeah. Yeah, so this is how we can implement a complex multi-line logic, and using the curly brackets, we have to put the body in the curly brackets. And the one thing we have to, if you are using the curly brackets, you have to explicitly return the data using the return statement. In earlier statement, it's a single line statement of adding, so we have not written any data. But when you are using the curly brackets, you have to return data by explicitly using the return statement. So, okay, so far we have learned how to create our own functional interface and implement the interface using Lambda expression. So now we are going to write a thread using a Lambda expression, because thread having a runnable interface which has a run method, so it has only one abstract method, so the runnable interface can also be considered as a functional interface. So to write that, first we need to implement the runnable method using the Lambda, and in this thread we are going to simply print 1 to 10 with using a small delay. So we first create a variable functional interface runnable, and then we are going to implement the run method using the Lambda. So the run method takes no argument, so we have just the parameter list will be empty like this. Now we have to implement the run method body, so we are going to implement using a curly brackets because it is a multi-line statement. So we are creating a for loop to print 1 to 10. So now we're using the system out. I just print out the number, but to print out is properly, I am adding a small delay of 200-300 milliseconds. So I'm adding a thread sleep method of, let's say, 300 milliseconds. Since you are using the thread sleep method, we have to handle the interrupted exception. Now, if we are going, now we have done with the implementing the runnable interface. Now we have to create a thread and pass the runnable interface as thread constructor, and then call the tstart method to execute a thread. Okay, so now if we are going to execute this program, let's say, so it will print out the number 0 to 10 in a sequence. So this is how we can implement a thread using a Lambda expression. This is the end of the course, and we have learned what is functional interface, how to write a functional interface, how to implement a functional interface using the Lambda expression, and how to implement the existing functional interface like runnable, comparable, or callable interface using the Lambda expression. And I will come up with a new video on the functional interface where we will discuss in details the new functional interface introduced in Java 8. And thank you for watching this video. And I request all of you kindly subscribe to our channel. Thank you.